Good morning, good afternoon, and good evening, everyone. So today we're going to be going deep into singular value decomposition and interpolative decomposition, right? Because we did touch upon these in a previous video in our scientific computing series, but we weren't able to go deep into it, and so we'll actually do that. But here's the high level, or here's the bottom line of all of these decompositions, whether that's singular value, interpolative, LU, those types of stuff. The only purpose of doing those is to make it more efficient, to make our programs or our code more efficient to run, right? Really high level, we want to make it more efficient. That's it. And now you might be asking, why are there different ways or different strategies? Well, I guess some work and some don't. Some are more appropriate for some problems, some are more appropriate for other problems, right? And so here, basically, when we're learning these types of decompositions, well, we're being introduced to different kinds of tools, different kinds of decompositions, so that we'll be able to use them whenever we need them, right? Okay, so let's go over a brief review of singular value decomposition. Basically, we decompose our matrix A into three things, three stuff, right? Here we're saying that U and V are orthonormal. What do we mean by orthonormal? We mean What we mean by that is when we multiply that matrix by its inverse, we're gonna get an identity matrix. That's why they're orthonormal. That's basically what it means. So here, we already kind of mentioned it here. When our matrix is orthonormal, then that means when we multiply them, it's going to be an identity matrix. Identity matrix is basically when it's diagonal. Say this is a 2 by 2. When it's diagonal, it's just 1. That's an identity matrix, or it could be something bigger. Something like that. And just to highlight there. So those are different kinds of identity matrices, different sizes of identity matrices. Okay, and so here, I'll just get into the example because this is, yeah, it's mostly proofs here. So let me just go to an example here. I'll make it nice and slow. Okay, so first let's do singular value decomposition. So let's say we have our matrix A. This one is 3, 2, 1. And I think this was 1, 2, 3. So that's an example of a matrix A. Now we want to decompose that into U, sigma, and V transpose, right? We want to decompose it to that. So how do we do that? Well, okay, here's what I'm gonna do. I'm gonna go to code because I don't like handwriting these because it's hard. So I'm gonna go directly to Python and do them. Okay, let me share my screen here. Python. There we go. Okay, so we want to do an SVD. We call it an SVD, a singular value decomposition. So here's what we're gonna do first. We're gonna import our library NumPy because that's for working with these types of stuff. We're going to define the matrix A, right? So how would matrix A look like? Well, that's just A. Then we're gonna make an array of stuff, right? So here we have 3, 1. Here's basically what we have. Oops, my bad. Okay, let me do this. Okay, there we go. So here I have 3, 1. Then this was 2, 2. And then this was 1, 3. Right? So that was our array. I messed up again. Oh, okay. This has to be inside. I'm gonna do this. There we go. So that's our matrix, right? That's how it looks like. Okay. So the next thing we're gonna do, we're gonna compute the SVD. So the reason why I'm doing it in code is because uh, this requires linear algebra. I haven't taken linear algebra, but here I'm gonna show you guys why this, or no, I can't show you the in-depth math solving. I'll do that when I take a linear algebra course. So here, I'm gonna compute the SVD of our matrix A. So that's gonna be, what is this? U S V T SVD of A. That is a built-in Python function, apparently. Specifically, it's this dot. So we don't have, yeah, linear algebra. Apparently, that's a thing in NumPy. So we're doing it automatically with code. And here we're gonna say full one of our parameters here. I'm gonna set the true. Okay. So here we're just solving it. The next thing we're gonna do here is we're going to reconstruct our matrix A using the SVD. And so we're going to convert our S, sigma, the sigma matrix, with the same shape as A. That's what we're going to do. So we're going to reconstruct A using SVD. So again, there's some math going on behind this. I can't do the handwritten math for now. I would if I know, but not now. So here, I'm just going to say sigma and np dot zeros. I think it was a like or zeros like. Yes. And then this is a, so here we're reshaping or reconstructing. There we go. And then we're going to fill up the diagonal. Oh, that's why. So here when you notice sigma, our sigma in the decomposition, that's going to be a diagonal matrix, meaning only the positions at that diagonal have numbers. In the off diagonal terms, they're all zero. So we're gonna fill that diagonal, fill with S, right? We're gonna fill it with the values of S. Oh, whoopsie, sigma with S. Okay, and then from there, so that's our sigma, and then we reconstruct that whole thing. So A, I don't know, A reconstructed equals something. Our U, our sigma, and our transpose, right? So U, sigma, and transpose. Okay. And then from there, what are we gonna do? We're basically gonna print out everything. All right, we've done it. We've done the whole thing. So here's what I'm gonna do. I'm gonna print out everything. I'm gonna show it one by one, right? So here, I'm gonna print everything. So here, you print matrix A, and I think I can do this. Let me do this. Put F there. Ah, there we go. Then here I'm gonna do A. See if it prints out in a nice way. There we go. Nice. So it did print out. It's a bit weird looking. Is there another way to do it? Or I could just do, that's fine. It's one line anyways. I'll just do this. Uh, do this. Ah, there we go. And then just print. Okay, cleaner. That's cleaner than print A. Right. So same idea, I just made it. Okay. And then from there, I'm gonna print out. So this is our original matrix, right? It's a 3 by 2 matrix A, which has these elements or components. And now we're gonna compare it with some other stuff here. So now let's look at the decomposition. So let's look at U. What is U? Because it's decomposed into 3 things, right? It's decomposed into 3 things. Okay, wait a minute. It's gonna, because I'm actually storing my recordings, so I'm just checking them. See if I can convert some of them. Okay, I'm just gonna. Yeah, I have like a couple of recordings. Put your